Today we're going to talk about our last type of factoring, which is perfect square trinomials. So we're going to start off by looking at these two examples. Now with our first example and our second example, you're going to notice that these are trinomials. So we have two cases here. Again, I'm going to use decomposition for both. This is how we would normally start off without really knowing what to do. So I'm going to start here with my first example. Now it is a simple trinomial, just to review decomposition because you can use that. I have to find two numbers who multiply to 9. 1 times 9 gives me 9, and who adds to 6. So when you're thinking about that, two numbers that multiply to 9, add to 6, those two numbers are 3 and 3. So reviewing decomposition, my first term stays the same, x squared. I decompose my middle term, which means I break it down, and I use my two magic numbers, plus 3x, plus 3x, and my last term stays the same, plus 9. Now what I can do is I can group them. I have my red group, I have my green group. What can I common factor out of my red group? X squared and 3x. Well, I can common factor out an x, which leaves me x plus 3. Then I can common factor out of my green group, which leaves me, I can common factor out a positive 3, which gives me x plus 3. And we have here, these two pieces are the same, so I can common factor out my binomial, which leaves me with x plus 3 times x plus 3. Now what happens here, again, what you'll notice is that these two are the same, they're the same binomial, which another way I can write that is x plus 3 all squared. Okay, now, again, if you remember that this is a simple trinomial, I can go right from this step to this line, or kind of this line, once I know my numbers, because the coefficient out in front is a 1. So that's a perfect square. What is a perfect square? When both binomials are the exact same. So let's try this next example. What I have here, again, I have this one here is now our complex trinomials, because I take A and I multiply it by C, so I need to find two numbers that multiply to 25 and that add to 10. And again, we know here that the two numbers that multiply to 25 and add to 10 are 5 and 5. So what do I do here? I have to, again, keep my first term the same, 25x squared, decompose my middle term, plus 5x, plus 5x, and then I have the 1. I'll group my terms together. So what can I common factor out of my red group? 5x, which leaves me 5x plus 1. What can I common factor out of my green group? Can't common factor anything, which means I'm actually common factoring out a 1, which leaves me 5x plus 1. Again, I'll know I did it right when these two pieces here are the same. So I can write out 5x plus 1 times 5x plus 1. And since these are both the exact same binomial, I can rewrite that as 5x plus 1 all squared. So one of the key things here is I'm going to show you a way today to go from here to here without having to do decomposition. You can always do decomposition on this, but like when we had these as problems and we were asked to expand, we used a trick. Well, we're going to use that trick to reverse it. To help us out here. So these are perfect square trinomials, which means that when we factor it, we have the exact same binomial, so two of the same thing. Okay, so it says here, factoring a perfect square trinomial results in binomials. Each bracket will be the same. The difference is that both the first and last terms are perfect squares, and the middle term is 2 times the square root of the first term times the square root of the last term. Okay, so we're reverse kind of engineering what we did for our special products when we expanded. So what we have to do here is we have to do a check. Check 1 is, can I take the square root of the first term? Yep, I can take the square root of a squared. The square root of that is just a. Can I take the square root of the last term? Square root of 16. I can do that. I get 4. Okay, so I can do both of those. So that's kind of check 1, check 1. Now, what I have to do here to make sure this middle term is the one that I really kind of need to check, because this is the only way that I can use this trick here. So my check would be, I take my a with the square root of the first term times the square root of the second term, which is the 4, so I'm kind of color coding it for you, and I have to double it. So a times 4 times 2. What do I get when I take a times 4 times 2? 8a. If this is the same as this, we don't have to worry about signs here. If that is the same as that, then I can use this trick check, or this trick here. So what's my trick? I have to perform this check. When I perform this check, and if it works, I can use this method. If it does not work, you have to use decomposition. So first step, take the square root of the first term and put it into each bracket. Well, I already know what the square root of the first term is. It's a. Step 2 says take the square root of the last term, put it into each bracket. That's 4. Step 3 says take the sign of the middle term and put that into each bracket. Minus. And then I put a squared there. That is it. So the only way I can do this is if I check to make sure that that middle term is the same when I do my check. So my final answer is a minus 4 all squared. Again, you would get the same answer if you had to find two numbers who multiply to 16 and who add to negative 8. Negative 4, those are the same brackets, so we have a minus 4 all squared. But now I'm just doing it in really one step here. Okay, this next one. So again, my first clue here is I'm going to look at my first and my last term. Can I take the square root of this first term? Yep, when I take the square root of that, I get 5a. Can I take the square root of the last term? Yep, I get 4b. So now I'm going to do my check. I'm going to write it off to the side here. So I'm going to check here. I take 5a. I'm going to multiply it by 4b. And then I'm going to always double it. What do I get when I do 5 times 4 gives me 20, times 2 gives me 40ab. Is this the same as this? Yes, it is. So I can use my trick. So what will I do? I write 5a, take the sign of the middle term, minus 4b all squared. Okay, let's do the next one. So again here, I have, okay, can I take the square root of the first term? Yes, I can. 144, when I take the square root of 144, I get 12x. And can I take the square root of the last term? Yes, I can. I get 1. So now I have to do a check. So I'm going to do my check down here. I'm going to take that 12x, times it by 1, and I always double it. When I multiply all of that, 12 times 1 times 2 gives me 24x. So that's good. So now I can use my check. Now, do you actually have to write this check out? No, I'm getting into the habit. Some of you may want to get into the habit to check it because it doesn't always work out. So my final answer here will be bracket 12x, take the sign of the middle, minus 1 bracket squared. And that's the final answer. Now for this next one here, so if I go ahead and I take the square root of the first one, I don't get a nice number. So I can't really use my trick. But if I look here, geez, these are really big numbers. Can I common factor anything out? Well, it turns out we can. We can common factor out a 2. So when I common factor out a 2, I'm left with 4, 4z plus 36z, sorry, 4z squared plus 36z. And then when I do 162 and I divide that by 2, I get 81. So there's my common factor. So now I'm going to look, I look at my numbers here. Well, I have some perfect square numbers here. If I take the square root of the first term, I'm left with 2z. If I take the square root of the last term, I'm left with 9. So what can I do here? I have to do a check. So I'm going to do my check. I'm going to take my 2z times it by 9 and double it. And when I take 2 times 9 times 2, I get 36z, which is good. So that means I can use this. I always have to carry down my common factor, which is 2. My final answer will be 2z, take the sign of the middle, plus 9 bracket all squared. Okay, hopefully this is going okay for you. Just going to move this check piece over here. Okay, my next one here. So if I look here, what I'm going to do is I'm going to, okay, I noticed that my first term, can I take the square root of it? Yes, I can. I get 10z. Can I take the square root of my last term? Yes, I can. I get 11. So now I have to do my check. Okay, so my check is I have to take 10z times 11 times 2. And what do I get when I do 10 times 11 times 2? I get 220 z. Is that the same as my middle term? No, it is not. So I cannot use my trick here for this. I would have to do another method of factoring. Now, for the purpose of today, we're not going to. These numbers are really high, and I won't give you a question like that. But we would just say that this one actually is not possible. I'm going to tell you right now, you will have all of your factoring on your test will be possible. But just for this example here, I just wanted to go over why this one is not possible because the check does not work out. Okay, our last 3 examples here that we are going to do. So again, here I check, can I square root the first term? Yes, I can. It's 5a. Can I square root the last term? Yes. 4b. Can I do a check? Absolutely. So I take 5a times 4b and I double it, which gives me 40ab. That works out. So my final answer here becomes 5a minus 4b all squared. Okay, my next one here, again, can I take the square root of my first term? Yes, I can. It's m squared. Can I take the square root of my last term? Yes, I can. It's 3. Let's do a check here. I take m squared times 3 times 2, which gives me 6m squared. Is that my middle? Yes, it is. So when I write my final answer, I get m squared, take the sign of the middle, plus 3, and then all squared. Okay, this next example here, again, we're going to look at it. I can take the square root of my last term, but I can't take the square root of my first term. So again, here, this one for our case would be a not possible one because I can't take the square root of my first term. Okay, so you have a worksheet that you are to complete for homework. That's your first thing that you're going to do. You are then going to be given a review once you finish your worksheet. Your review, again, I will be collecting on Thursday. You will have today and tomorrow to work on your review. There is an additional review online that you can go on to our class website to get if you would like an additional review if you feel like you need more practice.